Okay, so let's continue. So a few things. There were some group changes. There were some changes in the group assignment, so we'll update the PDFs again on Blackboard. I removed them from now, so we don't have those legacy assignments floating around there, just for clarification. Cool. So, yeah. So what happened as of now is, one of the aspects that was just highlighted here, when you create an instance, ensure that when you create or pick an image, and it requires a certain capacity, right? Like Windows is generally about 10 gig or something like this, and Linux around 2 or 3 gig. Ensure that you pick a flavor that is large enough to support that hard disk requirement, right? So if you have a machine that is too small and doesn't support that, then you're obviously up for trouble. So let's see. I think tiny is. So it has already a disk size of 10 gigs, so that would be sufficient. But if you take a one that is insufficient, you could run into trouble. So, okay, coming back to our little exercise here. So we created the class instance just before, this one here. And now the question is just how do we get into the system. So I mentioned something about floating IP address before, right? So we need to make it accessible to SkyHigh. Right now it's really in its own private network, like down in the bottom there. Not even SkyHigh can access the particular IP address there, right? So because you could have all the same kind of subnet there, but you need to have a globally valid IP that somewhat operates on this level here, so we can actually use this jump host to get into your virtual machines. So we do that by assigning floating IPs. I believe all of you have a pool of 50 floating IPs you can use. So there's also constraints there, but they're quite moderate. And that's basically, quite straightforward. You simply, I timed out. Let's see where I end up here. But it should be, So you need to select the instance you want to associate it with, which is the one we just had. And then just choose a floating IP. It will be dynamically allocated from a pool. The network you need to be choosing is XNet. That is basically the external network from your machine's perspective, because that is linked to the internet, and just allocate an IP. So you can't control the particular IP. You just need to take what you get and associate it. But then the IP you should be able to be using from SkyHigh. Cool. So that's the associated IP now. I'll just copy this one. So just bring up what I'm doing here. So this is Putty, for example, and I just want to connect to SkyHigh right now using my username and password, and surprise, surprise, it ends up on the other screen. And then I'm basically in SkyHigh, right? So we made our first step into SkyHigh there. So cool. So if you see that over here you have a considerable number of private keys already, well, 2 right now. Another key.pem and ntnu.pem. So I had copied them onto that machine before, right? So the instructions again are in the slide set. I will clarify that slide set a bit and upload it again. It has the instruction of how to do that, how to copy the files. So what I'm doing now is basically I want to connect to that particular machine, right? So the floating IP is 172.16.133. Again, note here I indicates that you provide a private key. That is here in this case another key. That is the one that is associated with your instance here as linked here. Yeah. So it's important that you pick the right one. If you pick the wrong one, obviously nothing is going to happen. But if you do that one, you're kind of sweet. Since it's a new machine, the client-side cache of SSH, yep.
How do you know the username?
Yes, because that's something we discussed. It's built into the image because the username suddenly doesn't matter anymore. You don't set up an explicit user. Default user is Ubuntu on Ubuntu images. It's a matter of specification and documentation of the cloud environment you're using. Yeah. So yes, but Ubuntu in our case. Here the client-side SSH tool says, well, I've never seen that machine because it can't if it has just been created, and you need to accept the fingerprint of it simply by typing yes one time. So that's quite normal if you connect it to a machine for the first time. Obviously, that shouldn't happen again afterwards, because at that stage, your client should know that's that machine. Cool. So now we're basically in an instance, and we can do our usual stuff. So we are basically have a baseline installation of Ubuntu. One thing that I do by default is generally to run an update. So apt-get update, because you never know how old the images actually are that you're dealing with. So it's worthwhile just to run update and upgrade afterwards. And it will tell you, well, there's 150 meg of packages to be installed. Let's just do that. So, thus far, we basically just have an running instance that we can use or not. That's the key idea there. Let's put a web service on it, so we'll see that actually something is happening. Should be nearly done. Yeah, do a bit of configuration. Take a bit longer than I would like to. You can also have you note that you can collect arbitrary number of times in principle, right? So you could have a second connection to that server that basically does some other stuff. So it's basically up to you now to do any sort of operation. So instead of waiting for this in entirety, probably it's worthwhile talking about the idea of the concepts behind Docker first before we start playing around with this. So, so now we know IIS frameworks, so basically such as AWS or OpenStack in our example. But it's important that we understand what actually Docker is about and where does it sit, how does it relate, why do I yet introduce another kind of concept. Who knows Docker? I'm not surprised. Anyone else? Yep. Okay. Yeah. So, what is Docker?
It's something that allows you to ship software.
Yep. Cool. Yep. Anything else?
Probably in some simple way can think about it as just like an instance or often like a container that inside you have a virtual machine or something. So it's like you can start an instance inside this container.
Okay.
When it's like on the stock or like on this OpenStack.
Yeah.
For example.
Okay.
So you can create a machine from the beginning to download some code or get some connect to repository and install some few things at the start.
Yeah.
And create this Docker file to make everything like a snapshot maybe you showed it, and put it into the Docker, and then when you start the Docker, then there's everything inside is running itself.
Cool.
So you can just kind of copy servers, machines, whatever you need.
Yeah.
Like on the run.
Okay. Cool. So.
But
Yep.
Docker is something like it's for shipping. That it doesn't matter which system it's running on. It's running inside this Docker.
There you go. Okay.
Then it's kind of a closed environment.
Yep. Okay. So one of the keywords that you mentioned was the container, right? So container is exactly what it's all about. Jonas, do you want to add anything? There was some.
It's also. I would like to add that it's not a virtual machine.
Yes.
But it
Okay.
could replace a virtual machine. But it's much more lightweight than
Right.
a virtual machine.
Right. So.
It's actually.
Yep. So that's exactly the essence. So bringing your answers together gives us the whole picture. That's precisely the idea. So it is lighter or much more lightweight than a virtual machine. So it's not a fully fledged machine with operating system, but in fact just a what you refer to as container, right? And the container really concentrate on the application level code that is relevant for you, that you want to actually run. Meaning, you don't think so much about the underlying operating system and configuring, installing it, but actually on the application that you're interested in. And the benefit there, I think that's highlighted there quite well, is that you have a shippable solution, right? So that has been mentioned as well. I think some notion of interoperability, like you're kind of reasonably platform independent, right? So if you, as soon as you have a Docker image or Docker file rather, and you want to run it, you should be able to run it on any sort of Docker platform, right? So using that as a basis, right? So, but fundamentally to highlight this or to compare it is, when we talk about virtual machines first, I'm going a bit back here, so we have the entire stack of complexity in one go. Conventionally, when we think about operating system, we have something like the physical hardware, right? So including operating systems and application on top of it. Now in OpenStack, for example, we're moving away from this, right? So we basically have physical hardware somewhere, right? No idea where it is, probably quite a lot, but then we're sharing this hardware across different VMs, yeah? So we have multiple virtual machines that have virtual hardwares. They have virtual graphic cards, virtual storage. Again, like we just assigned a certain amount of block storage for each VM, right? But what they all need to do is they basically need to install their own operating system again. So there's a lot of redundancy involved there. So not do you only have the underlying infrastructure that virtualizes hardware, but you have yet another operating system operating on that virtualized hardware. Yeah. So which is really a lot of complexity, a lot of abstraction layers, and frankly, it's also a lot of loss of performance. It's a lot of inefficiency simply by asking a system to rebuild hardware, which you're just using to, you know, run software again. Basically, it's just for the sake of having a complex virtual machine, and obviously gives you the whole flexibility to do anything that you can do on a machine, perhaps apart from gaming really, because usually I/O is not, or GUI is usually not amongst the strengths of virtual machines, if you have experienced that, like in VirtualBox, for example, right? So you can use it for like abandonware perhaps, but not for contemporary titles. So, but now if we move one step further, right? So on the virtualization is not virtualization. So it's different, there are different characteristics. And we're dealing with type 1 and type 2 virtualization in the default case. So on the far left, you see a dedicated system that has underlying hardware with a hypervisor running on it, which is the virtualization software basically, directly running on the hardware. And on top of it, the individual VMs, virtual machines. Yeah. And in all cases, do you see, like, you know, again, the operating system, the guest operating system, libraries that they need to have, and fundamentally the application that's running on top of it. Yeah? In type 2 virtualization, you that has a bit more complexity. You basically have hardware, a host OS, and then on top of this operating system, you run what's called the hypervisor. Yeah. Again, that's basically like the virtualization framework you're interested in. And then on top of this one, again, you have the individual VMs. Yeah, yeah, please.
Is OpenStack type 1 or type 2?
What's your guess?
I hope it's type 1.
Right, so...
but maybe, I don't know.
Yeah, it's a mixed bag. Technically, it's running a Linux, it's running on a Linux basis. So it's kind of a hybrid because you can't pin it down to an individual machine. In fact, it literally just sits kind of in between. So because you still can theoretically install other software on the underlying hardware, but let's say the abstraction with Linux is reasonably small or small enough or efficient enough that it allows to do that. Secondly, OpenStack in itself is a set of software services. It's not so much an entire hypervisor or operating system, because in that left case, type 1 virtualization, the hypervisor itself has operating system functionality built in. And that's quite limited in the case of OpenStack. So we're sitting more between the fences here because it's distributed. What is a classical type 2 hypervisor though is, any example for a classical one? Yes, right, those desktop ones, like VirtualBox, VMware, and those ones that sit on top of your client system. They are definitely a type 2 one, you know, and that's how they operate. But again, a lot of inefficiencies, rebuilding the entire idea. So now looking at Docker as the third variant here, we're actually minimizing the abstraction here to some extent. And the idea here is that on top of the underlying hardware, we still have a host operating system, so we stick to that, and the associated libraries. So there could be, for example, C libraries running on the host. network applications, control commands, and so on, which are all basically part of the core utils and libraries provided by Linux, for example. But on top of it, as yet another daemon means background service, sits Docker itself. So it's sitting there as an application service, and it allows you to instantiate applications and their corresponding libraries in individual containers. So you run multiple containers. But the key thing here is that those containers are actually using or have access to the host libraries and to some extent to the host operating system, so they can use it. So what's the good part about this? Yep.
Only one OS.
Cool. Yep. Fundamentally, you're only operating with one underlying operating system, so a lot more efficient in terms of actually using the hardware instead of having multiple layers of inefficiencies on top of that one, right? So only one operating system. Cool. Yep. What's another advantage? Anyone? No other advantage? Look at the containers. What's the evident thing here? Yep.
They don't contain an OS, so they are smaller.
Which means they're massively smaller, right? Because they effectively only contain whatever you want to run, right? So they could be in the realm of megabytes as opposed to gigabytes. And then you can imagine, yep.
And you can spin up much faster also. It takes maybe a second to spin up a new container versus spin up a virtual machine may take, like you
Yep.
saw on OpenStack,
Yep.
many minutes.
Yep. So, yep, definitely right. So startup time is massively reduced because you're using basically everything that's sitting here anyway. You're just hooking your container into the operating system functionality, using that daemon that mediates this whole idea. So you can be much faster spinning up individual containers, right, repeatedly, and various variants of this one. So, yep, is there a possible risk or problem that we see here? What's the disadvantage of this over, for example, this approach, virtualization approach? Yep. Anyone?
Security.
Yep.
Like when you have a virtual machine, you can say that the instructions will be either I don't remember the name right now. Yeah, if they are dangerous, then the host operating system will take care of it, whilst you can't do the same sort of version of that.
Yeah. So you're right. So you think about user space and kernel space operations, or system calls and so on. So you're right. So if you have an underlying operating system that guards any application access to the underlying core, right? And here, this same functionality is basically only guarded on that level, on the host OS level, right? So basically, any potentially malicious activity could potentially trickle down up to your host operating system. So there's definitely a security risk to some extent, foremostly because the Docker daemon itself has root permissions, right? So because it needs to be able to access a lot of system level functionality, networking, hard drives, things like that, it needs to have elevated privileges. So, and that makes it kind of dangerous-ish, yes. Yeah. Yep. Cool. So that's part of one of the challenges. In fact, there's a lot of argument whether this is actually a context or a system that you would consider virtualization, right? So because it technically doesn't really virtualize the underlying functionality, but it directly has abstraction layers for invoking it. So, and we get to that in a second. The idea is that Linux operating systems have a notion of what's called control group C groups. And they allow you to use the same kernel from multiple, for example, Docker instances. So they have independent process IDs, user IDs, things like that. But they're fundamentally using the same underlying kernel. So if your Linux kernel breaks or is insecure, all your containers sitting on top of it are potentially vulnerable, right? So the argument there is, well, since it's actually using native host or operating system functionality, it's not virtualization. So it's not really a classical virtualization abstraction sitting between any Docker container and the operating system. But the idea, the core benefit is simply the isolation of individual containers. Yeah, so you can have a complete specification of your application configuration as part of one single container that is totally independent of a second one. So you can change your environment for this particular container, but from the perspective of a second container, it will look unchanged, or this container can customize it itself. That includes environment variables, names for files, user IDs, instantiated users, installed services. So a lot of that stuff basically is isolated between individual containers, even though they're technically using the same underlying operating system. So it's kind of a bit of magic going on there. But there's even, there's a considerable fight in the community as to whether it's called application level containerization or virtualization. So be mindful of that. You might find yourself in critical environments if you make a claim for one or the other sides. So the metaphor, I just put it up here, it's quite straightforward, but for anyone who struggles with the metaphor, I think one way to think about it would be to compare to virtual machines, compare containers to virtual machines in the form of houses, right? So if you have a house, you have a fixed dwelling that has all the infrastructure, roof, kitchen, entry, windows, all that kind of stuff. But if multiple people live in there, like let's say applications, to keep that metaphor going, they would need to share that infrastructure, right? So, for example, in your flat, I'm not sure if you're flatting, for example, there may be even something like a bathroom schedule, right? So you can't just use the bathroom at the same time, right? Because it's shared infrastructure, yeah? So in containers, the idea is there, well, we have the same kind of fundamental functionality, right? So you still have, access to water and power and all that kind of stuff. But we have some kind of abstraction level sitting in between that hides the fact that you're actually sharing the infrastructure, the underlying infrastructure. So each application can be slightly varying in terms of its configuration environment, such in an apartment, for example. Everyone has kind of a kitchen, but it's slightly different in all individual apartments and can be used concurrently at any time. So that's the key idea. You're basically sharing the underlying infrastructure instead of building N houses. Yeah, so that's just the fundamental concept here. And technically that boils down to using those, again, I mentioned those control groups briefly, literally carving out access to CPU, memory network, and storage, or I/O. So by individual control groups. And each individual control group is associated with one Docker instance. So they basically, again, actively share your underlying hardware, or underlying resources. I'm not going into the details there, but that's basically the idea. So now looking at Docker. Docker is not the only container solutions. There have been others before. LXC was the native one built into the Linux kernel, but it was fairly expensive to use and not expensive, but very inefficient to use in terms of its configuration. And I think one of the key merits of Docker that it's so reasonably simple to create new application instances, and that it's absolutely independent from the underlying operating system. So that makes it such a strong concept. So Docker is about simple use. It should be speed, so speed of instantiating new containers. There's an entire ecosystem which is called the Docker Hub, and it's kind of the equivalent of the GitHub for containers, right? So whereas you find code in abundance for any sort of open source software, good and bad, on GitHub, you find pretty much any sort of container configuration for Docker, good and bad, so be mindful of that, on Docker Hub as well, right? So it's a kind of environment to do that. So, and then one of the other aspects of Docker, something we're not getting into probably today, not anyway, but not tomorrow, is that you can modularize and structure your application in different modules and bring them up or down concurrently or in a combined setup. So for example, database and application server should be separated into different Docker containers, but you can control them at the same time. And nevertheless, and that was similar to what was mentioned before for snapshots in OpenStack, you have a layer-based approach. So if you build a Docker container, you can instantiate it, change it, and commit it again. So you have a changed version that builds on an existing Docker container. So the idea is having a layer of commits that make up a Docker image, as it's called. Yeah. So that's the key idea there. Right. So I would like so perhaps to get started, we're obviously not getting far because, as usual, I just want to highlight you guys may be inclined to do a quick install of Docker, and the default command on Ubuntu environments would be to do something like apt install docker.io, but I would like you not to run that because it installs Docker 12, which is an outdated version. Instead, I would like you to install a more updated version, which is version 17, because we will use some of the features that have been introduced over time. And so we did some of the, let's see if I can finish up that installation. There's a few instructions involving this in the slide set, so you can run at your own convenience. And those are a set of commands. I just copy and paste them in. One of them is basically, here this one installs the underlying requirements, prerequisites packages, most of which are installed already. The next command is actually downloading, I didn't copy it, sorry. Then next command will basically download the, hang on. The key for the Docker repository, so you can download software from there and basically authorize Linux or Ubuntu in particular, apt here, that's the software we're using, to actually download from this repository. So we need to manually introduce the key for this particular repository. Then we add this repository. Nothing we need to memorize at all. It's just about following the instructions there. So it's adding a particular repository that directly downloads from docker.com as opposed to using Ubuntu repositories. Because Ubuntu is notoriously, or various distributions are notoriously behind in customizing available packages for their operating system. So sometimes you need to fall back using other solutions. We did the same for Go, right? So the Go installation, the default installation Ubuntu was outdated, so we need to do the manual download and install of that system. And it's pretty much the same here. And once we have done this, so we added this repository, we can run apt-get update, which says, please provide me an updated catalog of all available software for my machine. And you notice that it now downloads the overview of packages from the Docker URLs as well. And then we can install Docker CE. So it's pretty much, that's the final bit. And this would install Docker on the operating system. So even though it sounds tedious now, it looks tedious now, it's actually only a few commands away. And then we can start actually bringing up the Docker container. I'll just, before I let you go, I'll just run a classical example of actually figuring out that it works is to run sudo run hello world. So, and then we'll talk about what it's actually about. So, right, so hello from Docker, that actually works, the installation works. I can briefly tell you what it's doing here in its background, but only very briefly. Is actually down, it's looking up in the Docker repository, is looking up the image hello world, because I just said Docker run hello world, so it expects there to be some image called hello world that it can instantiate and run, right? So, and it does so using the Docker infrastructure, so in the background actually downloading it from the internet. And it's a very small package, so it's basically identifying it as part of a Docker library, so it's library hello world. It downloads the latest version of it, and then runs it. And that basically just says hello from Docker. It's just a test environment. So, but we go into the commands tomorrow in greater depth, and you can run Docker images, and you find now, well, we actually now have one image here. So the repository is called hello world. It's the tag latest. So it's similar to GitHub versioning. So you can have individual tags associated with particular commits, you know, version 1, 2, 3, 4, and so on. Same here, latest is the default tag to get the latest commit for that particular image. It associates an internal unique image ID, and well, it gives you the size. And the size happens to be, well, 1.84 kilobytes, so literally nothing, right? So that's how it basically works. But this is obviously a very small example. For bigger images, the story is quite different. So I leave it at this because there's little point digging deeper right now. But what I would like you to do, and I put the slide set up, is to get into OpenStack, set up your own instance there, and install Docker as far as we've gotten there. The instructions will be, the instruction for setting up the the PEM file will be in the previous slide set, so I will update this one based on suggestions just now. And the instructions for getting Docker onto the image will be in the current slide set. I will upload this after that very session. Yeah, so you need to browse through that a bit one. Yeah, and then we'll see each other tomorrow again, continue here, and hopefully get something Dockerized and going. Any questions? No? Totally lost, or everything is okay so far?
I have a specific one.
Yeah, okay, but okay, yeah, we get to that. But other than that, everything's. Yep,
is
please.
17 the newest one?
I think it's the latest one, if I'm not mistaken. Yes, yes. Yeah. If you find a more recent one, go for it. But I needed certain features, and I know they're available in 17 onwards. And 12 is just notoriously behind. Unless, I mean, this Hello World thing runs in older versions as well, but the more advanced stuff that we'll need for our work, particular for automating Go builds, is only in higher versions. Cool. Well, thank you very much. See you tomorrow.